Hello, I'm Sienna Bowes, and welcome to my channel, Learningbuildslife. And today we're going to talk about an Olympiad standard sum on geometry. I'm going to read the sum before we can begin. Which of the following statement is false? Okay, out of these four options, A, B, C, D, we need to find the false statement. So let's take a look at each of the statements. Option A, two diameters of the circle will necessarily intersect. We can demonstrate or illustrate this with the diagram. This is the center, O. Let's say O. And I'm drawing a diameter through the center, A, B, and another diameter with joining two ends on the 2 points on the circumference, P and Q. These two diameters both intersect at the center, so any two diameters on the circle, and anyways, a circle has infinite number of diameters, all intersect necessarily at the center. So this is a correct statement. So it is not false, and we did not get our answer yet. The diameter of a circle is always in its interior. Yes, this is true, because it can never be like this, that the diameter goes in the exterior outside the circle. It always stays inside it. Hence, this is also true, and B is not our correct answer. Every diameter of a circle is also a chord. This is true, because a diameter, it flows through the center, but it joins 2 points on the circumference. Like in this case, this diameter joins points A and B on the circumference of this circle with center O, and also this diameter joined P and Q. Those are another set of 2 points on the circumference of this circle. And finally, option D. Every chord of a circle is also a diameter. This is false, and I'm explaining why with the diagram. In this circle, again I'm taking center O, I've drawn this chord, which is joining points, let's say M and N, on the circumference. This line, which joins points M and N on the circumference, does not go through the center. And that means it's not the diameter, but that does not mean that it's not a chord, because anyway, the definition of a chord is a line in a circle that joins any 2 points on the circumference. So even though this is a chord, it's not a diameter. So all chords are not diameters, but all diameters are chords. So finally, we got our answer, that is D, because this is the false statement which we wanted. I'm giving you a few moments to look at these two diagrams and understand how we got the false statement. Now we will discuss about another Olympiad standard sum on geometry. So this is our next sum. Read the following statements carefully and select the correct option. Statement 1. A sector is the region in the interior of a circle enclosed by an arc on one side and a pair of radii on the other 2 sides. Statement 2. A segment of a circle is the region in the interior of the circle enclosed by an arc and a chord. Now I'm reading out the options. Option A. Both statements are true. Option B. Statement 1 is true, but statement 2 is false. C. Statement 1 is false, but statement 2 is true. And both statements are false. Now, according to the statements, we can identify which one is the correct option. So let's begin. First, let's look at statement 1. A sector is the region in the interior of a circle enclosed by an arc on one side and a pair of radii on the other two sides. This is nothing but the correct definition of sector of a circle. So this is a correct statement. This is true. I'm going to demonstrate a sector with a diagram now. Circle, center O. Now, two radii, and it's enclosed by two radii and one arc. Over here, I'm shading this sector. Here it's bounded by radii OA and OB and arc AB. This is one sector of the circle. This is a correct statement. Now, moving on to statement 2. Statement 2, a segment of a circle is the region in the interior of the circle enclosed by an arc and a chord. This is also nothing but the correct definition of segment. So this is also a correct answer, correct statement. Now I'm going to demonstrate a segment using a diagram. Again, a circle with center O, chord joining points M and N on the circumference. This is one segment which is bounded by chord MN and arc MN. So this is one of the segments of the circle. This is in the interior and also it's matching the entire statement. It's enclosed by an arc MN over here and a chord MN over here. This is a segment and this is the correct statement. So both statement 1 and statement 2 are true. Both statements are true. So option A is the correct answer. I'm giving you a few moments to look at the board and see these diagrams really carefully and correlate them with statements 1 and 2 so that it can sharpen your concept. Hope you enjoyed this episode and please like, share, and subscribe to my channel and stay tuned for more videos. Thank you.